Go. Look at you go. All right, so number 1 from our homework was y equals 4 times the square root of x. And if you didn't do your homework, just go ahead and write a 0 on a sticky note. Yeah. Okay, so remember, our tables that we practice in our notes are really good and helpful, so you should have done the same thing. So we have x, 4 root x, and y. Now, did we change anything under our radical? So should we still use our perfect squares to plug in? And what are the perfect squares that we plug in? Look at you go. Now you get a point. Does everybody agree or disagree with that? Cool. I love it when one person answers and the rest of you are just in la la land like you think this doesn't matter and like you're going to pass my class if you don't get this right. All right, so what's the square root of 0?
0.
And what's 4 times 0?
0.
Fantastic. And now we plug in 1. What's the square root of 1?
1.
And what's 4 times 1?
4.
Somebody tell me what my next y value is going to be.
2. Well, 8, but
So you have the square root of 4, which is,
2.
and then 2 times 4 is,
8.
okay?
8.
And what's my last y value going to be?
It's going to be 12.
Why?
Because the square root of 9 is 3, and multiply 4 times 3 to get 12.
Fantastic. And what do I need to do after this?
Graph.
Graph it. Now, do I need to go below my x-axis at all on this one? No, I do not, because I don't have any negative x values or any negative y values. Do you think that this 4 out front is going to stretch our parent function, or is it going to flip our parent function? It's going to stretch it, because when you multiply by a whole number, it stretches it. Take a point, Jarek. Who can tell me what the first point is besides Jarek to plot?
Oh, 1, 4.
No, the first coordinate. The origin, 0, 0. Thank you, Henry. Take a point. All right, Dylan, what's the next point that we plot?
1, 4.
Good. Take a point. All right, Troy, what's the next point that we plot?
I'm still looking at I don't know where I put it.
So you can't look at the board?
Oh yeah, sorry. 9, wait, G spot 4, 4, 8? Okay, 9, 12. Wait, no. 4, 8. Sorry.
Take a point. And what's the last one that I plot? 9, 12. 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 8, 9, 10, 11, 12. And it did stretch our parent function. And by how many units did it stretch our parent function?
4.
4. Take a point. She also got it right.
No, but I said it first.
She did. You said it. Okay. All right, so have we moved our function any other than stretching it? Have we moved it left or right?
Right. No. What?
We're still at the origin, so we haven't moved it any. We've only stretched it. Thank you. Number 2 that we had to do last night for homework, you only had 2 problems. That's it. It's crazy. Obviously, not your math.
Yeah. Well, we do that.
All right, so y equals negative 5 times the square root of x. The what? The t-table. Okay. No, I got an email about a student and needed to check it.
0, 1, 4, 9.
Why do I use 0, 1, 4 now? Not
Six
one.
squares.
Yeah.
Perfect squares. Hold on. All right, work it out. Those of us that didn't do our homework. Those of you that did do your homework, what do you get to do? Relax. Breathe. Check your work. Stop dancing.
Why can't I dance? It's America.
Did you do your homework?
Yeah. I'm just redoing it.
Lies.
So I know I make it right. So,
What is the negative supposed to do to our graph this time?
if flip it, you make it negative, or what? Go down.
Bring it back 5.
It flips it. All right. CJ, tell me the first y value that you got.
0.
Awesome. Adam, tell me the second y value that you got.
5.
Positive or negative? Negative. That's okay. We just needed to watch our signs on that one. I probably didn't write that negative big enough. That's my fault. I got excited. All right, Manny, both of you get a point. Manny, tell me what you got for your third y coordinate. No, baby. What's the square root of 4? And what's 2 times negative 5? Manny, earn your point and get the next one without me. And without Alexa. I know, but she wants to. She feels bad for you. Be glad one of us does. What do you do with this number?
Square.
Square root it.
Square root it.
Oh, well, same difference. You was gonna get it right.
They're both telling you the answer in Spanish and English, and we still not getting it. What's the square root of 9? What's 3 times negative 5? Thank God. How many of us got that without it being as extremely painful as that just was? Good. Take a point. Graph it without me. You don't have to plot negative 15. At least go to negative 10 then. Plot the first 3 points. I would make my graph look like this. Because we don't need any positive y values, do we?
No, we do not.
Cool.
Cool.
We do need 0.
You're funny.
You're funny looking.
You're funny looking.
Nope.
Look at you. You're beautiful.
What does beauty funny look like?
Keeps it off my face. You have hair like this.
I mean, I can't.
Okay, then I don't think you need to be judging. With your little dyed twist up there. Looking like worms coming out of your head. You want to do that? We can do that, boo-boo.
Please, all right, let's do it.
All right, does everybody's graph look like this? Okay. Are we ready to see what happens when we add or subtract?
Yeah.
Fantastic. All right, so go back to this foldable. We're going to do these last 2 things, and then we're going to do our activity, and it's going to be great. Now, if I wanted you to stretch it, which Flappy would we use? The first one, second one, third one, fourth one, or fifth one? If I wanted you to stretch the graph,
Second.
we would use this one where it's a times the square root of x. All right, if I wanted you to flip the graph,
Third.
third. Good. Now, what do you think this guy right here is
Moving
going
to
to
the
do?
right.
How?
Because it's under the thingy mabob.
Is that k under the radical?
It seems like it.
No.
No.
Yes, it is.
Yeah.
Yes, it is.
I mean, it's not stretched out far enough.
This one isn't stretched out all the way, is it?
No.
Now, do you guys remember when we had this noodle right here?
Yeah.
And we had an H and a K, right?
Correct.
Okay, so this K right here, it said that it moved it up or down. And this was vertex form of a quadratic. So what we're doing today is vertex form of a square root. So what is the K on the outside going to do?
Move it up.
Move it up. If it was a minus, it would.
Move it down.
Fantastic. Okay. So I want you to write stretch beside this. I want you to write flip right here. Oh. And then on the next one, we're going to write up or down. Are we ready to practice?
Yes.
Just remind me of what I'm giggling at the end of class so I can ask you this question. Just remind me. All right, now, did we change anything under our radical?
You added something.
But did we add it under the radical or on the outside?
Outside.
Outside. So if we don't change anything under our radical, we still use the perfect squares. So 0, 1, 4, 9. But this time after we take the square root, what are we going to do? Are we going to multiply or are we going to add?
You're going to add it. Yeah.
Now, it's the square root of x plus 4. Not the square root of x plus 4. It's the square root of x plus 4. So please write a plus 4 here, and a plus 4 here, and a plus 4 here, and a plus 4 there. And what's going to change each time? The number under what?
No, right.
Good. All right, so what's the square root of 0?
0.
And what's 0 plus 4?
4.
Fantastic. What's the square root of 1? And what's 1 plus 4? What's the square root of 4? 2 plus 4? Super sorry. And what's the square root of 9? 3 plus 4? Awesome. Are we ready to graph it? All right, so what's the first point that we plot?
0, 4.
So I don't go left or right any, but I go up how many?
4.
Okay, and then?
1 5.
And then?
4, 6.
And finally?
9, 7.
Now, did this one stretch our parent function any, or did it just move everything up?
Move everything.
It just moved everything up. And if I wanted to move it down, what would I do?
Subtract.
Subtract. Fantastic. You ready to go to the next one?
Yeah.
What do you think it's going to do when it's on the inside? So far we have stretch, we have flip, we have up or down. What's left that we could do?
Go down.
No, guys, this one is up or down.
Oh.
If we subtract, it would be down. We add, it's up. So what's the last thing we can do? Okay. I flipped, right?
Right.
I've gone up the stairs, I've gone down the stairs.
Go right up the stairs.
I could go right of the stairs or I could go left of the stairs. So if it's a minus, under the radical, left or right? So up for this one would be plus, down would be minus. Let's figure out how we go left or right. Is everybody ready?
Yeah. Would you multiply it and then subtract it by something?
Well, do we have anything to multiply it by?
No, man.
So what do we do?
You just take the square.
Can I use my perfect squares this time?
It's not negative.
If I use 0, what's going to happen?
If you use 0,
If I plug it into the radical and I use 0, I have 0 minus 3, right?
it could be negative.
And can we take the square root of a negative?
No, we cannot.
Okay, so first we need 0 as our output. We need 0 as our final number. So what number can we subtract 3 from to get 0? 3. All right, so we're going to start with 3. Ashanti. Muchas gracias. Okay, now the next output I need is what?
What are we doing next?
Perfect squares. We're trying to get to our perfect squares. So it's 0, then what?
1,
1. Okay, so what number can I subtract 3 from to get 1?
2, 4,
2 minus 3 is,
4, 1.
so we need 4. 2 minus 3 is negative 1.
Oh,
All right, what's my next perfect square? It's 4, right? So what would I subtract 3 from to get 4?
7.
Mm-hmm. So all you do is add 3 to your perfect squares. Troy, are you with me? Are you sleeping in your hammock that you've made around your
Yes,
neck?
very nice,
Or
okay.
okay.
It's comfortable.
Why would you get 12? Why would you say that?
Because 9 plus 3.
Yep. All right, so now to show you guys what I did, I'm going to write on the side that right here, I did 0 plus 3. Because that's my perfect square, and you do the opposite of what's under here. Then I'm going to do 1 plus 3, because that's my next perfect square. And then I'm going to do 4 plus 3. And then I'm going to do 9 plus 3. If I was adding under the radical, what would I have to do right here? Subtract. Are we ready?
is that part mandatory?
Yes.
Just write it on the side and stuff?
Oh, the green?
Yeah.
No, but these numbers are. This just helps you see the process of how we did it.
Okay.
All right, so we have the square root of 3 minus 3.
0.
And what's the square root of 0?
0.
Awesome. Next, we have the square root of 4 minus 3. What's 4 minus 3?
1.
And what's the square root of 1?
1.
Look at us go.
Also, you subtract it and just take the square root.
Yep.
Okay.
Next, we do 7 minus 3, which is, and what's the square root of 4? Cool.
I'm guessing you have
And finally, we'll do 12 minus 3. And what's that? And what's the square root of 9? 3.
Did you need it?
Okay, so now, are we starting at 0, 0 this time?
No.
Where do we start at?
3.
3, 0. So on my graph, I'm going to go right 3. I don't go up or down any. And then what do I plot?
4, 1.
Mm-hmm. Then what do I plot?
7.
And finally, do we have enough room for 12? No. Okay, connect them. And da-da-dun. So did we stretch our parent function or did we move it to the right? We moved it to the right. So if you subtract, it moves it to the right. How could we move it to the left? We would add. All right. Get out your handy dandy sheets that are in the sheet protectors.
So I had to get a note.
And keep your notebook out as a reference. I want us to stretch our graph. And I want us to stretch our graph by 6 units. So how would I do that?
I have no idea.
Because you haven't been paying attention for 2 days.
Oh, you gotta
6
put
square
a
root x.
you gotta put a
6
in front.
square root x. You got to put a 6 in front. Both of you get a point. So we have y equals 6 root x. Now, did I change anything under the radical?
You did not.
So what x values am I going to use?
You're gonna use perfect square.
And what's our first perfect square besides Jarek? And then, and I want you to add 16 to that bad boy.
Well, we're going crazy.
We don't go crazy.
All right? Do your process column. Tell me the y values. Go. Then we're going to graph. This is your practice time without me. Everybody should be doing this.
So bigger the t table, the more we can go down.
Yep.
Okay.
Everybody should be doing this. And before we graph, we're going to hold them up.
Did we get it right? Did we get points?
Yep.
You was just getting lightheaded, now you want to dance.
I want to stand still for so long. And I had some water. It helps. Thank you for your judgment. Effort.
We only worry about the same.
All right, are we ready?
Not yet.
CJ, I would check one of your y values. Not that one. That one's fine.
Cool.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Hold them up, hold them up, hold them up. Let me see, let me see, let me see. Good, good. So close. Good, good. So close. So close.
You're done.
Good. Last one is
Oh, I added it.
I don't know what you're doing. You're saying nothing because you're not doing it. Good. 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 Good.
So to be done.
So close. It's a positive 6. Good. All right. So what? Don't erase. Don't erase. Don't erase. Unless you got it wrong.
Oh,
All right. What's the square root of 0?
0.
0 times 6 is
Get that one wrong.
awesome. What's the square root of 1?
1.
6 times 1 is.
6.
What's the square root of 4? 6 times 2 is. 6 times 2.
I got it right on the paper. I messed up.
Square root of 9 is. 6 times 3 is.
18.
Square root of 16 is. Square root of 16 is.
Oh, wait. You're right.
4.
4. 4 times 6 is.
24.
Yes.
Which one? Oh, I thought it was 29.
Graph it. Flip it over and graph it. Show me what it's going to look like. You may not be able to graph 24. You won't. But you can graph everything else. So I will leave my t-table up here. You flip yours over and graph.
So can we erase?
Wait, so we go right?
Can you flip it over and graph? Isn't that what I said to do? What should you be doing? Okay.